Alright, so we want to do an example problem. So let's say we have a ball and we're rolling the ball on the ground and it's going into a wall and our ball is moving at 10 meters per second and our ball weighs 1 kilogram. So our ball's rolling in, it's going to hit the wall and it's going to bounce off the wall and come off the wall with the speed of 5 meters per second. And it still weighs 1 kilogram. So what we want to know is, what was the impulse delivered to the ball during the collision with the wall? And if the collision takes place in 0.1 millisecond, or in 1 millisecond, what was the force on the ball from the wall? So to set this up, we remember that the impulse J is F average times the time, which we also said is the change in the momentum. So let's look at the change in the momentum to get the impulse, because we don't know the force. So delta P, we said, is mv final minus mv initial. So we normally count to the right as positive and to the left as negative. So when we're looking here, we say, oh, the mass is 1, velocity final is 5, and then we have minus 1, because the mass is still 1, but velocity initial is negative 10, because it points to the left. So what we see is we have 5 minus a negative 10 makes that plus 10. So the momentum of our system is 15 kilogram meters per second. But once you know the momentum, you know the impulse. So that answers our first question, that J is 15 kilogram meters per second. That's the impulse the ball delivers to the ball. Now, if that occurs in 1 millisecond, that means our average force would be J divided by the delta T. So in this case, it's 15 divided by 1 millisecond is 1 times 10 to the minus 3 seconds. So that means that the force delivered was 15,000 newtons during that time. So that's a really, really big force delivered to some ball. But that ball is pretty heavy and it was moving pretty fast. So this is just an idea of using the impulse momentum theorem to look at how a ball changes directions, because the average force is applied this way to the ball because the ball comes in and the wall changes the direction of the ball. Now let's take a look